All right, so part of the lecture that we have today, we're going to be talking about solving equations that are quadratic in nature. Equations that are quadratic in nature take on a form very similar to what we've seen for just normal straight-up quadratics. But instead of seeing x, we're going to see something called a u. And a lot of times that u is representing something that's a little bit more complicated, something a little bit more cumbersome and nasty. So you're going to see a constant here at the end if things are quadratic in nature. You're going to see some kind of variable expression here. And then you're going to see that same variable expression in the front. And it's either going to have a square on it or it's going to have double the power. And that's what we mean by things that are quadratic in nature. Now, we had some of these equations come up in the past. And I believe we even had an equation show up like this yesterday. And here's what we saw yesterday. So yesterday we saw this equation. We saw that it had 4 solutions, but notice how this guy is quadratic in nature. You've got your constant right here. You have some kind of weird variable guy that wasn't just x, but then you saw that the lead guy was the same guy with double the power, right? So it went from a 2 to a 4. You could have seen something very similar to being to another one being quadratic in nature. If this had been x to the 3rd, this guy would have had to have been what? X to the 6th, right? That makes it quadratic in nature. For some of these guys, like this one that we did yesterday, this guy just factors because you broke down x to the 4th as x squared and x squared, right? Well, if you can factor, that's going to be great. Otherwise, you might have to do something called a u substitution, so we're going to see that here in just a moment. So let's take this equation for an example. If I have 4 x to the 4th plus 19x squared minus 5 is equal to 0. You notice how similar this guy looks to the one from yesterday, right? Very, very similar. And yesterday we ended up factoring this guy, right? Let's see if we can factor this one. Now, I've got x to the 4th, so that means that if this guy factors, we're going to be splitting x to the 4th up as how? How are we going to do that? X squared and x squared. Right, we've seen polynomials that factor like that before. This lead coefficient, though, is not 1, so in order for us to factor, we need to consider what? What are we going to think about off to the side here? Okay, see, I was going to say do the AC method, right? I'm hoping this guy factors, so let's see if it does. Take 4 times 5. The product here is 20. Can you find factors of 20 that are going to subtract to give you the 19? 20 and 1. So those are the numbers I'm going to be thinking about, kind of off to the side. So when it comes to factoring, we can use the 20 and the 1, split up the middle term like we've done before, but we can also think about it like this. If I try to factor 4, if I just try to do trial and error, guess and check, how many different ways can you break down the 4? You can use 2 and 2 or what? 4 and 1. So you've got 2 options. So I don't know exactly which one to use just yet. What about 5? How many different ways can you break down 5? You can only do 1 and 5, right? You don't have any choices. 5 is prime, so if you're going to break this down, you have to use 1 and 5 or 5 and 1. The order doesn't really matter. So I'm just going to go ahead and say this. I'm going to say 1 and 5. Now, since we're supposed to get a 20 and a 1, whenever we factor, the 5 is the guy who kind of stands out to me. Is the 5 going to be used to form the 20 or the 1 when you do the inside and outside of the FOIL? He's going to be used to form the 20, right? So that means 5 times what to give us the 20? So it means this guy is going to be 4. That means 4 breaks down as 4 times 1. And we already talked about how x to the 4th is going to break down as x squared and x squared. Do y'all agree? Talk to me about your signs. What signs would you have to have so that you multiply to get a negative 5? You need a what? A negative and a positive, so which is which? What goes here and what goes here? If we do a negative 1 and a positive 5, that negative 1 times positive 5 still gives me negative 5. When you check the rest of this, this is a minus 1x squared plus 20x squared. So plus 20 minus 1 gives me the 19x squared. So we're good to go there. We factor this, and just like we saw yesterday, we can take each of these factors and set them equal to 0 by using that zero factor theorem. So 4x squared minus 1 is equal to 0, or the other factor, x squared plus 5, is equal to 0. So we take something that's big and nasty, and we break it down into pieces that are much more manageable. So talk to me about what you would do to solve 4x squared minus 1 equals 0. Am I just going to have to do this whole video by myself? We got to add the 1 to the other side. There you go. And then what? How do you finish getting x squared by itself? You would divide both sides by 4, right? Right, and now that you've got the square by itself, and only once you've got the square by itself, this is where you use that square root property. Take the square root of both sides, and you have to remember what? The plus or minus. So here, x is equal to plus or minus what? Plus or minus 1/2, right? The square root of 1 is 1, the square root of 4 is 2. Now before I go on, how many solutions did I expect from this equation? I expected 4 because of this. This guy gives me how many solutions? He gives me 2. Now since we were coming from a polynomial equation, I shouldn't have any issues with my answers. Whatever answers I get should work. On the other side here, x squared plus 5 is equal to 0, so x squared equals what? And now that I've got that square by itself, I do what? Use the square root property, and I must remember what? Please do not be frustrated if I keep asking you, what do we have to remember? Do not forget the plus or minus. So x is equal to plus or minus. How can I simplify the square root of negative 5? This negative comes out as an I. What are you going to do with the square root of 5? It stays as the square root of 5. It does not simplify any further. So you get plus or minus I squared roots of 5. We expected 4 solutions, and we have 4 solutions, 2 from here and 2 from here.